Today, I am going to be walking you through the RF behavior of both HD0 and DJI, taking a look at it on a spectrum analyzer. Now, this is the third time I have published this video. The first time I had to take it down because the audio wasn't right. The second time, some of the data was being taken out of context, specifically the way I was showing the carriers, because I was doing it at extremely short range on the bench, and there was some behavior people were seeing, and they were interpreting that not quite the way it should be. So I've decided to recut it. This is the third time. It is the last time I'm doing it. I hope you find it interesting. If you do, please hit that subscribe button. Please hit the bell. I could do with it after editing this video 3 times. Anyway, I hope you enjoy it. Now, I thought I'd just do this quick video to show you guys something and just do a little bit of myth busting as well around the behavior of one digital FPV system versus another. For instance, on the left here, we have the DJI digital FPV system, and on the right, we have HD0. You will often find it said that DJI is extremely difficult to use with other systems because of how noisy it is on the band. And whilst that in itself isn't actually true, there is some behavior you need to be aware of. What you're looking at on the screen at the moment is the 2 carriers from the digital FPV systems, both next to each other, being picked up by the same antenna, both set at 25 milliwatts. You can see on the DJI one, you have the main video carrier here with these little spikes above it, which is actually the telemetry feed from the goggles back to the air unit. So for instance, if I just take them off my head a minute and move them towards the antenna, you'll actually see those spikes go up above the video carrier, as you can see there. And then if I move them further away, you can see that it fades down more to the height of the video carrier itself. So DJI is doing its telemetry and RC control link on the same channel as the video. HD0 doesn't have this 2-way telemetry. So as you can see, we simply have our wide OFDM video carrier here. It is wider than the DJI one. So for instance, DJI is currently on 25 megs. And if I actually just do a measurement of the width on the carrier, we're getting about 18-19 megahertz bandwidth on that one. I'm a little bit wide there. So if we actually come in, you can see we're getting around 18 to the very edge. Or if I come out to here and a little bit to there, we're basically getting a 20 megahertz carrier width. And then on HD0, if we go to the same place, we're seeing about 25. I believe HD0 officially says 27, but you can see in their standard modes, they are about the same. Something that is worth mentioning is the why HD0 is a wider carrier than DJI, and the basics of that is DJI is a much more compressed system than HD0. DJI is using that compression to allow it to send as much data as possible, which tends to give better picture quality overall, but as a result of that, you have that variable latency and you have that blocking effect when the signal breaks up. HD0, on the other hand, is sending the data completely different, and that's why when it breaks up, you get the individual pixels fall away, so it's less compressed, and as a result of that, it is needing a bit more space on the RF band. It is, though, worth understanding that that has no effect on its ability to work alongside other systems. Both HD0 and DJI don't really take up any massive amount of space on the band that would affect the other channels, but DJI does have an effect on other systems because of a couple of other factors that we will talk about in a minute. There is, though, some other interesting behavior that you do need to be aware of with the DJI, and you can just see this right on the edge over here. This little flickering you can see here, and if I just move everything up so you guys can see it, there is a sort of timing pulse carrier that is transmitted next to the main carrier. So DJI does actually transmit some additional info on a different frequency, which HD0 doesn't. And just to demonstrate what will happen if I turn the goggles off, you see that that actually stops happening. And whilst the Vista has continued to stay outputting power, and you can see it sort of polling now, you can see this little carrier has stopped. But there is a random pole of data on the carrier that you can see there as well. If I just plug the goggles back in, you'll then see that kick back in. And actually, something now interesting has happened. You can see that the carrier on the DJI has increased substantially, and that is because it has powered up in 50 megabits mode. And now you can see that the carrier is much wider. We are on channel 8, and interestingly, it is still showing that carrier there next to it for us, which is DJI channel 8, not race channel 8. But you can see that we are actually getting that 50 megabits carrier even on channel 8, because I have booted in 50 megabits mode. Let me switch it now. You can see that that carrier has dropped. If I put it back to 50, you can see that it doesn't go back to 50. But if I turn the goggles off and power the goggles back on, when it connects, it will push it back into that 50 megabits mode again, as you can see there on channel 8. I just wanted to show this just to demonstrate how the systems behave next to each other. They are in some ways very, very similar, but there are some differences, and the big difference obviously is with HD0, you simply have this nice clean carrier. I'm just going to put the power outputs up just to demonstrate it a little bit higher for you guys. And I'm going to put the HD0 1 watt on 1 watt of output, and we'll let that kick in a second. And you will see that now switching in and going up, and that increase in output. Oh, I have overloaded my short saver. Let me turn that off and back on and power up. I drew a bit too much current from the short saver whilst powering both VTXs at the same time. There we go. We'll wait a second. And you're going to see some other interesting behavior here in a second on the DJI, which you've just seen. There we go. So we've powered back up, and you can now see that that HD0 is at that full maximum power output, which is up to 1 watt. And I'm going to put the DJI in the same position, which is 1200. We'll go to 1 watt as well. There is 1 watt, but I can set it to 1200 if we wish, which is there. And then once you do this, you can see both systems pretty much make a mess of the band when you're near them. But again, with DJI, mostly only transmitting over the top of itself with regards to the telemetry and RC. I am just going to show you guys one other little interesting thing as a difference between these two systems when you power them up, because this is the real fundamental thing that gets people. So what I'm going to do is set both back to 25 milliwatts, because it's important they're both on that mode. There we go. And what I'm going to do is power the systems down, and I'm going to power them up one at a time. And I want to show you how HD0 powers up and then how DJI powers up. And the DJI one is the one you really want to keep an eye on, because this is demonstrating the behavior that tends to be wiping people out. So I'm just going to power both systems down, and I'm going to clear the max hold. So when we power it on, we'll have a clear view of what's going to happen. So first of all, let's power up HD0. Again, set to 25 milliwatts. Boom, there we go. Nice and clean with just the video carrier kicking in. You can see there's no real anything else kicked in anywhere else. It is simply just that. And then you can see it there, nice and ready to go. However, let's turn off HD0. Clear things again and take a look at what happens with DJI, because this is the real interesting one. Here we go. So I'm going to power the Vista up. And remember, the Vista is currently set to 25 25 milliwatts of power. And just note the behavior once it kicks in. You can see the carrier has kicked in at a very, very high level. And then after a couple of seconds, it drops down to the actual power level that people have it set to. So the interesting thing is with the DJI system is when you power it on, it will always power on at full output and then drop down to the lower level. I'll just show you guys that one more time. We'll turn it off. You can see the carrier there was just the goggles carrier. We will clear the max hold and we will fire back on and wait for it to connect. You can see it's pulsing. Boom. You get this very, very large carrier of power, maximum output, and then that drops down to the 25 milliwatts that we've got the system set to. Now, we don't know the full output actual power that is, but if I do set it now back to 1200, you can see that at 1200, it doesn't actually reach that same high power level that it reached on power on. And it actually looks to be lower. So if we do this power on again and clear the hold, I've currently got it set to 1200 milliwatts. We'll power on. And what we'll then see is if it drops down from that 1200 milliwatt position, or to that 1200 milliwatt position, I should say, after a few seconds, it does. It clearly, on boot, is outputting much more power than the 1200 that I've got it set to, as you can see there. So it is rather interesting, and this is that behavior that tends to wipe other people's systems out on the DJI. One last thing I just want to talk about on this power on behavior is if it happens with a hacked or non-hacked air unit, because it was a question I was asked when I put this video out originally, and I actually answered it as yes, but that strictly isn't 100% correct. So what I'll show you is the difference, because there is actually a difference. At the moment, we have a hacked Vista set to 25 milliwatts, and we're going to power it on. And it will come on, even set at 25 milliwatts, with that massive carrier output that you can see here, and then drop down to that 25 milliwatt setting. And as I mentioned earlier, I do believe this is over the 1200 milliwatts that we're seeing on max power, and it is a very high output. What I'm going to do now is just pause, reset the air unit to not be hacked. I'm going to connect it to Assistant 2, remove the NACO file, and then I'll show you the behavior leaving the traces in place so you guys can see the difference. Okay, so the air unit has been completely reset, and I have confirmed it is now in official CE mode, 25 milliwatts. What I'm going to do now is power on the air unit and just show you the difference. So I hit the power, and again, whilst the final power output was the same, we'll wait for it to kick in. There you can see the power on behavior, and then it will then drop down to that 25 milliwatt setting. So the answer in CE at least is no, it doesn't go up to that increased massive output. And whilst it does go to a higher level, it is not remotely as high as we see with the hacked air unit. Just to do one other test, and this is with it set to 700 milliwatt mode FCC, but without the 1200 milliwatt hack. Again, the air unit actually set to 25 milliwatts. We'll power it up, and we'll see what the level gets to. Again, you can see that it does get that very large carrier, but it isn't quite as big as you get with the 1200 milliwatt mode, which you can see from the red traces either side. The conclusion that I've got on this is that basically the system always jumps to a higher output on boot, but what that higher output will be is depending on what mode you have. In CE, it is much, much lower. In FCC, it is higher, but not quite as high as it is with the 1200 milliwatt hack. One other quick thing I just want to show you on the power on behavior is just to show you what effect each of the systems have on the band around them. So at the moment, I am currently sweeping 5600 to 6 gigahertz. So I'm sweeping the whole FPV video band. I'm just going to clear the max hold so you can see it there. And what we're going to do is turn on HD0 first of all, just to show you what effect that has. So I'm just going to power that on now. And you will then see the video carrier appear down here. That's the video carrier on race channel 8. You can see that it is overspilling slightly, but I am at very, very close range here, down to about 5884, but it's not really going to have an effect once you're a few meters away. But you can see at power on, it had no real effect on the rest of the band at all. If I power the system down, you can see it turns off. If I clear that hold again, just to show you guys, power it back on. Ignore those spikes. That's just something on my local Wi-Fi kicking in. Let's see if I can just clear them again. Stop them coming back. There we go. And then turn on. You get a little bit of noise a second. Boom. But it kicks in. And overall, it is very clean. There is this little carrier here, but I am at very, very close range. I am not expecting this down at 5616 to be there at range. This is simply because I'm on the bench. If we just clear the max hold, you can see that really it is just that. What we're going to do now is show DJI. So the first thing I'm going to do is power up the DJI FPV goggles on their own. There's nothing powered up yet. You can see the markers just picked up a couple of things from my local Wi-Fi. That's all that is. That's nothing to do with the system. So I'm just going to clear that. I'm going to power the goggles up now on their own. You'll often get people say that the goggles transmit, and whilst they do transmit, they transmit no RF until the air unit is powered up. So you can see I've just powered it up. I'm next to the receiver through the spectrum analyzer. There is literally nothing at all appeared on the traces. I power them off again, power them back on. Again, what you're seeing there is just that Wi-Fi run through. Power them back on again on their own. There is literally nothing from the goggles at all. Now, what we'll do is power up the Vista. And we'll wait for that to kick in. And what you'll then see is that carrier kick in at that higher output first of all, which is what you're seeing now. You're seeing that kick in there. And then that carrier drop down to a lower level. I'm just going to do that again and just clear the hold just to show it to you guys, because you do see some other stuff appear on the band as well. We'll clear that again, power back on. But what you're seeing these is my Wi-Fi. So anything else you see appear, don't worry. It's not the DJI system. It's just my Wi-Fi. See, again, it's reappeared. If I was in a Faraday cage, I'd be laughing. But we're going to power the FPV air unit back on. And then you'll again see it connect, output that very high power level, which is here. And then you'll see it drop to a lower level. There you go. And now you've seen it drop with that blue being the main carrier, but with that red trace being that original output. And then we still have that little timing signal next to it that we can see here. These are simply my Wi-Fi polling when I fired the DJI system up, because it's detecting a signal on the band. But if I clear that, you can see the DJI is very clear. If I just move channels, just to show you guys that. So if we go down to, say, channel 3, you can see that the DJI system has moved down to channel 3. But that little timing carrier, that one there, always remains in place. And that is basically on 5800. It will always stay on 5800. 5805, but for all intents and purposes, it's on 5800. And that is then transmitted. And let me just look what that's transmitted from. Is it the goggles or the ear unit? So if I put the goggles next to the antenna, yeah, that is clearly from the goggles. And if I move the goggles further away, you can see that that signal has got smaller. So that signal is definitely from the goggles. And it stays on 5800. So again, it is making that channel unusable. But overall, DJI doesn't have a massive effect on the band, but it does do some stuff you need to be aware of. So if you were flying next to someone and they were using 5800, you're going to have a problem because that timing pulse will be on 5800 no matter what their video and telemetry channel is. Something else I just want to add into this is to show what the DJI goggles behave like on their own whilst your aircraft or the air unit is out flying. So what I've got at the moment is the air unit about 35-40 meters away from me, powered down, and it's going to be set on 25 milliwatts. And then I'm going to have the goggles in here next to me, next to the receiver. And I just want to show you the effect because there's often comments that the DJI goggles transmit a lot of power, which they do, but can also interfere with other people's analog receivers. And whilst that is the case, I'm firmly of the opinion this is more a problem with poor filtering on the receivers than it is DJI in itself, although you do need to be aware of some behavior. Now, as you can see on the screen, you've just seen some channels kick in. This is my local Wi-Fi. This is nothing to do with DJI. I just left it like this so you guys could see it. I'm just going to clear that, but it will reappear again. So if you see anything like that, don't worry about it. It's just the Wi-Fi sweeping the band from time to time. I could shut it down, but it isn't really important to demonstrate what we're doing here. So I'm going to run down and turn the Vista on, but what we'll do is power the DJI goggles up as well. So let me just plug the power in, and I've got it set to channel 8. So I've just powered the goggles up. And again, just to show you, there's no transmitting from the goggles. There's nothing at all. I'm just going to clear that max hold again, just to clear that. And then I'm going to run down now and turn the Vista on. And what you will then see is the signal from the goggles kick in, as well as the signal from the system. Obviously, the signal from the DJI system will be much, much lower. So, as you can see, everything has fired up, and you can now see that on DJI Channel 8, you have the goggle signal. In this is actually the video signal as well. So again, the RC telemetry and goggles telemetry link in 25 megabits mode is following the channel that the video is on. It is at a low level, but if I adjust this, you can see that that video channel is there. It looks quite noisy, but that is right down in the noise floor at minus 90 dB. Remember, dB is log, it's logarithmic. So whilst this looks bad, and this stands for the rest of this video as well, the noise you see down here, whilst it looks bad, it really isn't anything you need to be concerned about. Now, these goggles at the moment are about half a meter from the receiver. So what I'm going to do is just move it over, so have, say, 1.5 meters distance, normal pilot flying distance from each other. There we go. So we've now got the goggles about 1.5 meters from the Spectrum Analyzer receiver antenna. And again, what we can see is this pulsing carrier, which is transmitting on basically 5806 center frequency. So it's going to make that channel completely unusable. 5800 is going to be a complete no-no, which is channel 4 on the Fat Shark system, or on Raceband, it's going to be channel 5. But there isn't really any other interference being shown on the band. This here is my local Wi-Fi. You can only see that now simply because I've adjusted it. And then again, you can see those Wi-Fi spikes coming through. Let me just clear that back down. There we go. We have DJI and the goggles. So the goggles themselves are not particularly noisy. There is this behavior you need to be aware of, which is this single spike on 5800, and then obviously whatever channel the system is set to is going to show those carriers. But this is on the same as the video from the air unit side itself. One other just interesting thing I thought I'd show you is this is currently at 25 milliwatts. When you change the power output, and I'll go and do that now from say 25 up to 1.2, the goggles power output actually doesn't change. It appears the goggles side is fully dynamic, and it will only increase its output if it's needed, is from what I can see, or the goggles output is fixed. We don't actually know, but it doesn't change. So let me just grab them. So they're back a little bit closer now, as you can see. And what I'm going to do is look into the goggles. The audio might go a bit funny as I do this, and then change the power settings. So we're going to go from 25 to 200. No change. To 500, to 700, to 1,000, to 1,200. So there is no change in the output of the goggles when you're changing that RF power. If I just adjust the reference level, just so you guys can see that video carrier again, and again, the signal, I've kept it as low as I possibly can on purpose. This is right down in the noise floor. But if I change the power output, again, down from 1200 to 25, you can see there that the video carrier has disappeared. If I go through, you'll start to see that carrier come up right down here, and you'll start to see that power increase as I've been adjusting the outputs. However, the goggles telemetry link does not change. There is one last quirk of DJI I want to show you guys, and this is with regards to 50 megabits a second mode and channel 8. Now, officially, channel 8 doesn't support 50 megabits mode. When you move into that mode, you only get 3 channels plus public. The 3 channels will give you the 50 megabits mode, and the public will only give you 25 megabits a second mode. However, there is a quirk in the DJI FPV system that you can actually get channel 8 to give you 50 megabits as well. To do this, what you have to do is power your system up in whatever mode you want, whether it be 50 or 25. Make sure it's set to 50 megabits mode. Make sure it is not on 1200 milliwatts, so any power level below 1200 milliwatts, and then reboot the goggles. So right now we have the air unit on channel 8. I've turned the goggles off. I'm at 1000 milliwatts. I'm going to power the goggles back on. We're still on channel 8, and what you will see is the carrier jump wide, and it has jumped into 50 megabits mode on channel 8. Once you've done this, you can actually put it back up to 1200 milliwatts and reboot the goggles as many times as you want, and it will stay in 50 megabits mode. But to get it to kick this quirk of the system in, it needs to be on any power level except 1200 milliwatts. And once the system is powered up, you simply reboot the goggles when they're in 50 megabits mode, and you will then get the channel 8 to give you 50 megabits mode as well. Okay, so that is it for this video, and that is the third cut over. The biggest reason I redid this was because there was people interpreting some of the data that I was showing incorrectly or taking their own assumptions from it. For instance, the way I measured the two systems originally was on the bench right next to each other here, which made the carriers very, very large. It made them easier to see on the Spectrum Analyzer screen, but it also meant HD0 looked like it had a much larger carrier than it did in reality, especially at range. HD0 does output a bit more RF noise literally on the bench next to the receiver, but get a meter and a half away, that simply fades away to nothing. It is a non-issue. It doesn't exist, but people were taking that info and saying, look, HD0 is bad, when it simply wasn't true. So I've redone the Spectrum Analyzer bit so you guys can see it now in a more real world aspect. Now, the big take from this is as follows. HD0 is extremely good on the band, very little to no noise. It works well with analog, sits on race band channels, and basically integrates as you would have analog on the same system. DJI, whilst doesn't add noise, it does behave differently, and it does have some quirks that you need to be aware of. For instance, it has that extra carrier transmitting on 5804 roughly, which is going to play into problems for some people, and you also have that very high output behavior that you get when you power the system up, especially if you have the HACS applied. Even if you've set the system to 25 milliwatts, if you have the HACS applied, it will power on at an extremely high level and then drop down to the lower level. But if you don't have the HACS, the power on level is lower and as a result would have less effect on other people. I've often seen it said that people say the DJI FPV goggles cause interference, and there is no test that I have done that demonstrates the goggles transmit at all until they actually connect to the air unit. And in 25 megabits mode, they are generally always transmitting on the same channel as the video, and there is really no additional interference on the channel from the FPV goggles compared to anything else. But the real issue is people flying next to pilots who are wearing FPV goggles outputting quite high levels of RF, because whilst, as I showed you, the goggles don't change the RF level when you change the power, it is still a very, very high level of RF, and most receivers are not used to dealing with that level of co-channel interference very, very close to them. They are expecting your aircraft and other aircraft to be out at range, and that's why they're able to easily distinguish between the channels. But when you have a DJI user on the ground quite close to you, they're getting that high burst of RF on their channel. It might not be on your channel, but it does have an effect, and that is what causes it. Anyway, that's it from me on this one. I really do hope you found this information useful. If you have, please do consider hitting the subscribe button. If you'd like to support us to allow us to keep making content like this, please do check out the links in the description to my Patreon channel, as well as buy me a coffee. There is also links down there to my Discord server if you'd like to support us too. Finally, I'd just like to say a massive thank you to Aronia, who have loaned me this Spectrum Analyzer. We would not have been able to make this content without their support, and that is what I've been using today, which is the Spectrum V6, to show you guys how these systems actually work. So a massive thank you from me to them.